Hello friends, welcome to my channel. In this video, I will explain how you can perform the experiment of the drain and transfer characteristics of field effect transistor. Okay, so here we will use a trainer kit, patch codes and multimeter. So this is the name of the experiment and the equipment and components required, and then here the theory part which is for this experiment, and this is the symbol. This is the symbol and the internal structure, and this is the circuit diagram which we will use for performing this experiment. Okay, so at the bottom procedure written, and then you can see here for the drain characteristic observation table at different gate source voltage we have to take the readings of drain source voltage and drain current. Okay, so for example here taken gate source voltage of 0 volt, minus 1 volt, minus 2 volt and minus 4 volt. Okay, at these 4 voltage we have to take the reading of drain source voltage and drain current. And at the second observation table, this observation table is the observation table of transfer characteristic. In case of transfer characteristic, at different drain source voltage we find out the relation in between the gate source voltage and drain current. Okay, so then after we write down the result. See here result, we draw the graph in between the drain source voltage and the drain current in case of drain characteristic, and in case of transfer characteristic we draw the graph in between the gate source voltage and the drain current. Okay, so that's it. So let's start. For performing this experiment I'm going to use trainer kit. That name of this trainer kit is FET characteristic trainer kit. Okay, so here you can see symbol of FET is there. So just below inside this trainer kit FET is present, and here one resistor is connected inside. This is variable power source or voltage source that is used for drain source voltage. This is power on off switch, and this is variable voltage source. Okay, so this is drain source and this is for gate source voltage. Okay, so first of all I will show you the internal structure and the working of this trainer kit, and then after I will explain this experiment. Okay, so now here this is the internal structure of this trainer kit. Now first of all, now you can see from there supply line, this is connected to the supply line, this power cable, and then this goes to fuse. Okay, after that fuse I will show you. Okay, after that fuse this, now you can see after this fuse the supply goes to this power switch. Okay, after this power switch this goes to, now you can see this these two transformers. Okay, these two transformers step down the voltage, and here the first transformer is used to operate these two digital meters. So the first one is the voltmeter and the second one is this is digital voltmeter, this is digital ammeter. So now you see how the connection is. Now this is the wire, so this is the wire. Okay, so now you can see from here, from this transformer, these two wire are coming. So this is used to operate this voltmeter, and for this, now you can see from this transformer coming this. So here the output of the transformer, here one diode is connected and a capacitor to get DC, because for operating this digital ammeter we need DC, direct current. So after this transformer, you can see here one diode is connected, and after that one capacitor is that. So diode and capacitor converts into diode and filter that. Diode converts the AC to DC, and this capacitor filter that, and after filtering, this goes to this digital ammeter. In the same way, here in this case also, here you can see one diode is present here, so which converts alternating current to direct current. Then for filtering, the capacitor is used, and then you can see here on this digital voltmeter, this is the regulator. Okay, this is the regulator for giving pure DC. This is regulator. Okay, this is regulator, and here on this also, this one is the regulator. Okay, this these two regulators provide constant voltage for these two digital meters. Okay, and then you can see here from these two transformers, you can see here supply comes to these two bridge rectifiers. After these two bridge rectifiers, output of these two bridge rectifier goes to capacitors. Okay, so these capacitors filter the pulsating DC, and then after pulsating DC, after filtering, goes to, now here you can see regulator is also present. So this regulator provides constant DC. Okay, means there is no AC part after this regulator. Okay, so after this regulator, now you can see from here, so these wires are connected to this potentiometer, which provides variable voltage. And now you can see from this circuit, these wires come and connected to this potentiometer, and here the terminals are red and black terminals are there, which are used for providing variable voltage zone or variable regulated voltage. Okay, so that's what it is about the internal structure and working of this trainer kit. So now I am going to perform the experiment on this trainer kit. So this is the trainer kit, of which the internal structure I just now I explained. Now, according to the circuit diagram which I just shown in the beginning, now you can see this is the circuit diagram according to which I will make the connection. Okay, so now here you can see gate. Okay, so this is the positive terminal. So this positive terminal is going to connect, you know that gate source terminals are connected in reverse bias. Okay, it means the positive terminal of the variable voltage source is going to connect to source. Okay, so that's why here connected, this is the source. Now you can see this is connected here, so that's why source connected. And the negative terminal, see the negative terminal is going to connect to gate. Okay, so here I can connect here to the gate directly. So after connection to gate, what I'm going to do is to connect to the another terminal. Okay. And one more thing you have to keep in your mind, you have to uh, take the voltage across this FET. So it means you have to connect drain to this voltmeter. Okay, or directly I can I connected this drain to this voltmeter, and the other terminal, the source also I have connected to this, because in case of drain characteristic we have to find out the relation in between drain source voltage and drain current at various gate source voltage. Okay, so that's what I am doing here. So I have connected this voltmeter to drain source terminals. After that, now you can see this one is going to connect to this ammeter is going to connect in the circuit in series, so that we can find out what is the current which is flowing in the circuit. Okay, and the other terminal of the ammeter is going to connect in to the positive terminal of this drain source voltage. Okay, and now this one is going to connect here. Now connected. Now you can see I made the connection. So I think circuit here it is complete. Okay, one more thing we can do, we have to find out what is the gate source voltage. So for taking out the values of gate source voltage, I am going to use a digital multimeter. So this is a digital multimeter which I am going to use for finding out what is gate source voltage. Okay, so that's what it is. Now in the next stage, so now you can see I can connect this digital multimeter in parallel with this so that I can get the value of gate source voltage. Okay, so as I'm going to turn on this kit, now you see, so here I turn on the kit. So value gate source voltage here it is at minimum. वो है ये सर लिस्ट है सर, इस लैब में तो नहीं होगा सर, हाँ उधर होगा सर. Okay, I was telling, here you have, first of all, the gate source voltage is at minimum. So now you can see if I check gate source voltage right now, so here in the digital multimeter you can see the gate source voltage is 0. So here I can increase, if I increase, so now you can see here the gate source voltage it became 0.73. It means by rotating this I can change the gate source voltage. Okay, so that, and by using this multimeter I can take the gate source voltage. So what you can do, first at zero gate source, according to the observation table, at 0 volt of gate source voltage we have to find out the relation in between the drain current and the drain source voltage. Okay, so right now the voltage gate source voltage is 0. So at this gate source voltage I am going to take the reading, means I am going to vary this. So first of all minimize this. So drain source voltage is 0. So you can write down the value. So at 0 drain source voltage, what is the value? So now you can see the voltage across, or the voltage in between drain source terminal is 0. So the current through this is also 0. As I am going to increase, so now you can see here I am rotating clockwise. So now I increase the voltage to this. So this is the voltage, means you can see on digital voltmeter the value of voltage is 0.12. This is the voltage across drain source terminals, and the current is minus 1.0. So this here it is showing minus because the current it is in the reverse direction, that is it, nothing else. So as I am increasing, so now you can write down here in the observation table. Now you can see in the observation table you can write down different drain source voltage, and for those different drain source voltage you have to write down drain current. Okay, so now here I am varying. Now at 0.53 or 0.53 you can say the current is 3.8. again if I am going to increase, so continuously I am going to increase that a voltage 1.74, it is around 1.74, the current, the drain current is 9.2. so in this way you can write down different drain source voltage and drain current, and you can simply write here also in the observation table. So this one it was at 0 volt of gate source voltage. Now if we are going to increase the gate source voltage, now what I'm going to do here, you can see here. So in the digital multimeter right now you can see here in the digital multimeter it is 0. as I'm going to increase, rotate clockwise, now I'm rotating clockwise, now the gate source voltage it became 1.09, so around 1.09. so in that observation table it is 1, so approximately you can take. So at this gate source voltage again you vary this drain source voltage. Okay, you vary this drain source voltage, and you see by varying means what are the different drain currents for different drain source voltage. Okay, and again you can write down in the second part. So here you can write down drain source voltage and then drain current. In the same way you can do for different gate source voltage. Okay, so this one was about drain characteristic. Now I am going to explain about the transfer characteristic. So what happens in the transfer? First of all, turn off this, remove. So remove this all. So transfer characteristic. Now here you can see in case of transfer characteristic we have to find out the relation in between gate source voltage and drain current at different drain source voltage. Now you can see here. So this is it. So this is the transfer characteristic. So for different drain source voltage we have to find out the relation in between gate source voltage and drain current. For that purpose what I'm going to do, I'm going to connect according to this circuit. Okay, so this from here I can get gate current, here it is no. So here it is the relation, here it is gate source voltage and drain current. So gate source voltage, across this we have to connect a voltmeter, and we have to find out what is the current flowing through this circuit. Okay, in this circuit it means what is the drain current. So accordingly I'm going to do. Now here this is the positive terminal, so gate is connected in reverse bias. So now here I'm going to connect. So this positive terminal of the battery or the voltage source is going to connect here to the source, and the negative terminal is going to connect to this gate. Okay, after that we have to find out the voltage. Okay, voltage in between gate and source. So in between gate and source, how we can get? So this is the gate terminal, so that's what I'm going to connect to this digital voltmeter, and source. So this is the source, so to this source I'm going to connect to this voltmeter. So I can get what is voltage across gate source terminals. Okay, now the next step what I can do, we have to complete the circuit. For completing the circuit, now you see here, then you connect to this ammeter, then after you connect this to this positive terminal, and then after this negative terminal you have to connect here. Okay, so this circuit it is over. So first of all we have to set drain source voltage. According to the observation table, the first drain source voltage it should be 0.5 volt. Okay, for setting 0.5 volt of drain source voltage, I am going to use this digital multimeter. So this is digital multimeter I am going to use. So this is positive and this is negative. So first of all, turn on this trainer kit. If I turn on, so now the drain source voltage it is showing 1.53. So I have to decrease, because according to the transfer characteristic observation table, in the beginning we have to take you got 0.50. In the same way, by varying this you can get a drain source voltage 1 volt also, 1.5 volt also. Understood? Now what do we have to do? We have to vary gate source voltage. So this is the gate source voltage. By varying this gate source voltage, we have to see what is the current, means the drain current which is flowing in the circuit. Okay, so when the gate source voltage is 0, then in that case now you can see there is some current flowing still. Now again, if I am increasing this gate source voltage, now you can see as I am increasing this gate source voltage, now you can see there the current is decreasing. Okay, so these values you have to write down in the observation table. So at gate source voltage of 0.61, the drain current is 1.4. that's what you have to write down in the observation table. Further you increase this gate source voltage, now the voltage it became 1.2, around 1.2. okay, so at 1.2 gate source voltage the current is 1.2. so now you can see here, with increase in the gate source voltage the current is decreasing. So now again further if I increase, now at 1 point or at 2.0 around, so the current further decreased. It means with increase in the gate source voltage the current is decreasing, and these values you have to write in the observation table. So this is happening because when we increase gate source voltage, then the channel width decreases. Okay, because we have connected voltage source to gate source terminals in reverse bias. With increase in gate source voltage, the channel width decreases, which causes less current to flow through the channel. Okay, so that's it. So this is the way how you can perform the experiment. Okay, so this one it was the transfer characteristic, and in the beginning I explained about the drain characteristic. And if you draw the graph in between now, so now you can see here, this is the drain characteristic graph, it will come like this, and this is for transfer characteristic. Okay, that is the way you can perform this experiment. So hope you understood. Thank you. So don't forget to like, subscribe and press the bell icon to watch such informative videos on electronics lab and other related topics. Thank you, and write down in the comment section if anything you want to ask, on which I have to make the videos. Thank you.